opinions. As we continue talking about exponential functions, I wanted to talk to you real quick about a special exponential function called the natural exponential function. And that natural exponential function is this f of x equals e to the x power. Okay, e to the x power. E is not going to be a letter. E is going to be one of our rational numbers, kind of like pi. It's something that never ends, never repeats. Let me just show you where that is on our graphing calculator. If you look on right above the division sign, there it is. If I pull up E and then I just hit enter, it's gonna tell me it's this number that's 2.71828182, whatever. It's just gonna keep going. It's never gonna end. It's never gonna repeat. It's an irrational function, and where it comes from is that is the limit. It's a calculus term. It's the limit of this particular function. Okay, we're going to look at this here later in the week when we see some compound interest and things that are compounding and growing exponentially. Eventually, this is going to hit a limit, and that limit is when something's done continuously. We're going to use this e. But again, that's going to come up, and it's a very important exponential function that we have. We can see it also right here, right above that ln, which is the natural log. And that's because e and natural log are inverses of each other. That's why they're there. But we'll talk about logs and that next week. All right. But I needed to talk to you about e. E is not a variable in this case. E is a number kind of like pi. All right. What we really want to spend time talking about, and we shouldn't have to spend all that much time on it, is transformations. Okay. Our transformations. So we still all have the same transformations that we've seen all year long. Shift up, shift down, shift left, shift right, vertical stretch, reflections. Okay. So let's take a look at these. Now we're going to add to that the idea that we want to decide where domain and range and horizontal asymptote. So we're gonna add a little bit of complexity to what we've been doing, but not too much. Okay. Remember that most exponential functions have the horizontal asymptote at y equals 0. So we looked at yesterday, or you just watched in the video Friday. That horizontal asymptote is y equals 0 for most of our exponential functions. Okay, that will change if there's a shift up or down. A left and right won't shift that, but up and down will. So let's look at it. Again, here's our e to the x. Now, let me show you what that looks like, e to the x power. Let's go ahead and use Desmos. Okay, if I just type in e to the x, so there's e, and then let's see how it's that 2.71 number. It already knows that. Let's get it to the x power. Okay, there is e to the x. Notice its y-intercept is still 1 because anything to the 0 power is just 1. And then it grows. This is exponential growth because that base is something bigger than 1. It grows exponentially, right? Shoots up. Horizontal asymptote is still at y equals 0. Okay? So what would happen if we tack on a plus 1? Well, remember, if you tack on a plus 1 to the end of it, okay, anytime I add 1 to the end of it, that is a shift up 1. If I add 1, it's up. If I subtract 1, that would be down. Okay. So if I shift that whole thing up 1, now the horizontal asymptote is no longer going to be at 0. Now it's going to be at 1. Okay. Again, if I visualize that happening, shifting this whole thing up 1. Okay. If I tack on a plus 1. I can see that horizontal asymptote now is at y equals 1. Okay? So make sure you know how to identify that horizontal asymptote. Okay? The domain, since the domain was all real numbers to begin with, it's still all real numbers, or negative infinity to positive infinity. Okay? What about the range? Well, the range, because of the shifting up 1, is now going to be from 1 to infinity. Okay, again, if I look at that graphically, now the range is from 1 to infinity. I never get to this once, not an equal to. It's a horizontal asymptote. It'll go from 1 to infinity. Okay, I'm hoping this is starting to connect and make sense and be easy. Okay, all right, so let's look at the next one. We have our e to the x again, but now I've got a plus 1, but where's the plus 1? Now the plus 1's up in the exponent. It's happening only to the x, so that is a shift. Do you remember which way? If I add to the x, that's going to make it go to the left 1 unit. Okay, does that affect the original horizontal asymptote? Remember that original horizontal asymptote? If I take away this +1 here, horizontal asymptote's still at y equals 0. Okay, horizontal asymptote still at y equals 0. If the domain was already negative infinity to positive infinity, shifting it left and right 1 is not going to affect that either, right? If I do a +1 up in the exponent, I mean, it's still going to be negative infinity to positive infinity. No, I want it there. Okay, I want it, let's do a parentheses here. Exponent and do +1 that way. Notice it shifted it left, and it's not going to affect the domain. Okay, range, again, still the same thing. A shifting to the left didn't make it move up or down, so the range is still from 0 to infinity. Okay, all right, let's do the next one. Let's change this here. Let's change this to, let's change it to minus, just for fun. No, okay. Let's get out of the exponent that way and do a minus. There we go. All right. Okay, so next one. Notice that I started with 2 to the x now, and I've got 3 different transformations. Now I've got a negative in front. Okay, I've got a -1 happening up in the exponent, and I've got a -3 happening at the end. So I got to describe 3 changes. Do you remember what putting a negative in front does? It reflects it. Let's put that in orange. Okay, that's going to be reflect across the y-axis. Sorry, the x-axis. Reflect across the x-axis. And it's an outside change, so it's a vertical change. So that's going to make it flip over vertically. So the x-axis is going to act as a mirror. Okay? Again, just to show you that one thing at a time here, let's put our y equals 2 to the x. Okay, there it is. Still has that 0, 1, because if I put in a 0, anything to the power is a 1. Okay, now watch what happens if I put a negative in front. Boom, it just flipped it over the x-axis. Okay. Does that affect the domain if I do that? No, it still goes from negative infinity to positive infinity. Okay. Now I have also to deal with this -1. Now the -1 is happening up in the exponent. Okay, so the -1 is happening only to the x. Remember, when I subtract from the x, only the x, that's going to make it shift to the right 1 unit. Shift right 1 unit. Okay, again, that still won't affect the domain. Okay, now the -3 at the end is a shift down 3. Okay, so now the horizontal asymptote is no longer at 0. Now it's going to be at y equals -3. The domain is still from negative infinity to positive infinity. Okay, so now let's think about it. We may have to take a look at the picture in just a second, but it got reflected, it got flipped over. So my range cannot go from 0 to infinity. It would go from negative infinity up to 0, but then I'm also shifting it down 3. So now that would be from negative infinity to -3. Okay, again, when you flip it over, vertically, it changes your range to go from 0 to infinity. So now it's going to be flipped over. And then you're shifting it down to have that horizontal asymptote at -3. So again, just to verify what we got, we have a +1 happening up in the exponent. Sorry, -1 happening in the exponent. Let's put that in parentheses. Up there. Notice it shifted it to the right. Okay, and then I put a -3. Okay, now that shifted everything down. So that y equals -3 is where the horizontal asymptote is. And now that it goes from negative infinity up to 3. It doesn't go from -3 up to positive infinity. It's from negative infinity to 3. Okay? All right, one last example. Again, I'm trying to get you guys to make the connection between all the transformations we've done and what it does to the domain, the range, and the horizontal asymptote. Okay, last example. I have 3 to the x. Okay, changes now. Now I've got a times 2 happening in front of that. Okay, the 2 doesn't have the exponent, so the base is still 3. 3 still has the exponent on it, so that's still the base. We're not changing the base. Okay, and now the x has a negative. Okay, let's use a different color on that one. Let's use that color. Okay, now the x has a negative. So, do you remember what happens when I do a times 2 in front of a function? Doing a times 2 in front of the whole function is a vertical stretch. Okay, that is a vertical stretch. That times 2 is a vertical stretch by a factor of 2. Okay, now the negative is happening only on the x, so that makes it reflect. Negatives, multiplying by negative always makes it reflect, but now since we're multiplying on the x, now it's a horizontal reflection, so it's a reflect across the y-axis. You got to get those two reflections straight. The negatives in front is reflect across the x-axis. A negative on the x is a reflect across the y-axis. Okay, so we didn't shift it up or down, so that means that the horizontal asymptote is still at y equals 0. Okay, the domain can never change. If it's always all real numbers, then nothing's ever going to change that. Okay, now let's think about the range. Vertical stretch. Well, that doesn't affect the range. I didn't flip it over. I didn't move it up or down. Reflected across the y-axis, but then again, that also won't reflect the range. It will be from 0 to infinity. Again, let's just use little Desmos here to verify what's going on. Okay, so we got 3 to the x originally. Okay, there it is. Let's get familiar with it. Let's move this here. There's 3 to the x. Again, still 0, 1 is the y-intercept. Because you put in a 0, you're going to get a 1 because anything to the 0 power is 1. Okay. Now let's do all the changes. 2 times 3 to the x power. Oh, we needed a negative on that x, right? Okay, you notice, did you see how it reflected it and stretched it out? Now the y-intercept is at a 2, right? Stretched it out from a 1, stretched that out to a 2, and it flipped it over the y-axis, and there you have it. Okay, again, domain, horizontal asymptote still at y equals 0. Domain is negative infinity to positive infinity still. Range is from 0 to infinity. Okay, I wanted to just go over this stuff. I know we do a lot of these same transformations, so we should be pretty good at transformations. But keep in mind, you also need to be able to go the other direction. That if I give you these transformations, you need to be able to write this equation. So you got to be able to go both ways for all of these. Okay, write the equation or describe the transformations. Either way. Okay, and I wanted to make the connection back to the horizontal asymptote, the domain, the range. Okay, those are things that you're going to have to be able to demonstrate you know how to do in the assignment and on the test. All right, come with questions. See you tomorrow.